you get one inside and four outside. Some of you got two inside and three, and some of you maybe got five inside. You got three inside. Did somebody get one inside? You got two inside. Some of you got one, and some of you probably got that ribbon. Zero inside and five. One just came out. So how many did you inside? Sure, that was so good. You see, she couldn't tell me, but she could show me. And again, that's that visualization that I wanted to see. Now let me show you a couple things. These are some Amanda's representation of two inside and three outside. Jeffrey's representation of one inside and four outside. A little hard to see here, but it works. Now let me talk to you about the most important part of this lesson, though. I do this with all the different numbers they're doing, and it's a center, and but you see, I've got to do the math part. If all I do is have them throw, some kids are maybe getting parts of the number, but most kids are learning just to throw and going, yay, isn't that fun? I want to follow up. I want to debrief. I want to look for the patterns that I see. So I want you to watch what happens. I will put a big poster up. I'll have a small group of kids will read our notes that we've done. I will say, I'm going to put that little symbol here. What do you think that symbol means? And again, I'm just trying to get them to say a picture that could mean a word. So this is the inside, and this is outside. Now, I've done this a lot with kids, and here's what I know happens. Somebody will say, and by the way, I'm just putting the number here. Normally, I draw the parts out. I just was lazy on this particular slide. Sorry. But normally, I draw 5 boxes that were inside and 0 that were outside. Okay? Now, here's what happens. Because that's somebody always, I got 5 inside. Now, by the way, no one ever gets 0 inside. So Mrs. Copley always has to get 0. And I've even had kids say to me, you're not good at this game. I know, but they just keep doing it over and over again until they get it in. Now, I'll say, did anybody get anything different? That's a question we ask all the time, don't we? And then someone will raise their hand and go, I got 5 inside and 0 outside too. And I used to go into my speech about, is that different? Now let's think. I don't know if you have is that different speech, but I had one that I gave quite regularly. Until about 10 years ago, I realized that it was different because they did it. So what I do, when they say I got 5 inside and 0 outside, I just simply go back up to the board and I draw directly over the one that was just there. I say, how many did you draw? Okay. I got 5 inside too. Okay, 5, good. I go back and go 1, 2, 3, 4, 5. How many did you draw? 5. Great. I got 5. Okay. And I keep on going over and over. Finally, someone will say, we've done that one. I say, what do you mean? Well, when you do a 5 and a 0, you always get 5. And I'm going, yeah. You see? We missed opportunities because is that different? You understand what I'm saying? It's kind of an important point to take. Well, someone does 3 inside and 2 outside. And I put that up. And then, if you notice, I put the 3 up a little bit because what I wanted them to see is the pattern. Now, I wish I had drawn it out for you. I thought I had on the one slide, but I didn't. But you see how that's a pattern. And I want to set it up. I want to collect data so they start to see the pattern. Somebody will usually say, well, if there's 2 inside and 3 outside, there's 3 inside and 2 outside. And I'm thinking, yes, that's a user property of the show. You get that. They're certainly not naming it that or back. My aunt came back from Timbuktu. And brought me back. A tapping shoe. My aunt came back. From the county fair. And brought me back. A rocking chair. My aunt came back. From old Belgium. And brought me back. Gum, bum, bum, gum. My aunt came back. From old Chile. And brought me back. And itchy flea. Brought back. From the county fair. And brought kazoo. Some nuts like you. I did that often. That was just a verse I did because it was fun and the kids liked it. Actually, it had 3 more verses, but I can only stand it that many. I go crazy. By the way, this is on videotape. We'll sell the videotape later. Now, the point though is, if that's all I do, it's just a nice song and it's kind of fun. But it's actually a growing pattern. It's a +1 pattern. Because first of all, I do 1 action, then I add another action, doing 2 actions at a time, then I add another action. Think of all the verses you have that are +1 pattern. I can think of many of the songs that I sing with kids where you do one thing, you keep doing another, and so on. Now, I want to show you the kids doing it, because at the end, by the way, they do a little bit fun. I won't say that. I want to show you the kids doing it, but I want you to also know that I do a visualization after it. Because I believe children need to have a number. So you're going to see a stair-step pattern. That +1 pattern illustrated. And then after this, they went to centers and did stair-step patterns with blocks as well as with tiles and different things. So that +1 pattern is very important. Well, watch kids do it and you'll see that. And brought me back. A tapping shoe. My aunt came back. From the county fair. Watch me here and brought me back. A rocking chair. My aunt came back. From old Belgium. And brought me back. From the old Chile. Brought me back. Come on. And itchy flea. From the county zoo. And brought me back. Some nuts like you. The first thing was the shoe. And then the tapping shoe, very good. And the next thing was the rocking chair. And they still did all those other things too. Bubble gum. And then that famous one. I think you get the idea of what I was doing. This is William journal writing. He was doing patterns before he even knew what the numbers meant. 6767. This was at Halloween time. I think you can figure that out from the pictures. Snake game is one of my favorite games. And it is a game that allows children to, it's a game actually from South America. And what I like about it, in fact, let me have you play it for just a minute. Would you see if you could find, you're going to play with the person sitting next to you. Now, you don't have a snake board, but you're just going to do the parts of it. With everybody, if you can find 3 coins in your pocket, so you just need 3 counts. Okay? 3 counts. No, just you need 3 coins between the 2 of you. 3 coins between the 2 of you. By the way, in the state of Texas, break open, and they look like snakes. They've got divisions, and they take out the little seeds inside, and those are their counters. Now, the game actually, it's a board game where you move one step at a time from the head of the snake to the tail of the snake. And they move the counter along here. Whoever goes from the head to the tail and gets at the tail is the winner. Okay? By the way, you need to know this. I teach a lot, a lot of times people will say, well, I don't like teaching these competitive. Well, the fact is they are. So what can I do to do that differently? What I do is simply when they win, you'll hear yes. And when you lose a game, you go, oh well, because my games are all short and you play them very quickly and you play them over again. So, and there are enough random things part of it. Now, what I do with this is the way they move, though, is not by throwing duck. Okay? And you don't have a board, so you're not going to the way they move is they put 3 counters in their hand, and they don't tell anybody, but they put some in one hand and some in the other, and they can just do whatever. So they put some in whatever, and they say, guess how many I have in my hand. So there's a 0 in their hand, there's a 1 in their hand, there's a 2 in their hand, there's a 3. Okay? So guess how many I have. The person guesses, they didn't guess at this stage. They guess. And if their guess is right, they get to move that many spaces, the person who guessed correctly. If it is wrong, the person who has it in their hand gets to move that many spaces. Whatever, you're always going to move that many spaces, whatever's in your hand. You get the idea? So what I'd like you to do is with your partner, just say, do that, how many, they guess, and then Mark who will get to go first to kind of do a tally and see how far you can. Try it. I want you to see what's happening, okay? This is a very, very exercise. I have to admit, some of you one 10 frame and just one more. And I want them to see that picture of what that looks like. I want them to know that race for 21, I want them to know what 21 looks like. That's 5, 10, we fill it up, that's 11, that's 15, that's 20, and 21. Typically with young children, I'll do race to 11. That means filling it up to just 11. But since you were adults tonight, I thought you'd have a good time doing 21. Now, I'm not going to have you do it on the board because, number one, there's too many of you to have boards and you don't, based on how hard it was to find 3 coins, you may have trouble finding 21. So we're not going to do that. But instead, we're going to do it orally. Now, what you're going to do is you're going to turn to your friend because here's how you move. Here's how you move. You can either put in 1 or you can put in 2. So I can say 1 and you can say 2, 3. Or in other words, you're putting in 2. So watch, let's play it with this and then there's a counting way you can just do it. And whoever says the 21st one or the 21st number is the winner. Okay? So you have to think ahead a little bit. So watch. Let's say somebody wanted to say, what do you want to do? 1. Okay, so I put in 1, and then I might put in 1. I could put in 1 or I could put in 2. Then let's say you put in 2. I might put in 1. Or I could put in, well, I just put in 3 because I put 2 more. But you get the point of what you can do. Whoever puts in the 21st one is the winner. Now, if I'm counting, because you're just going to count, you have to visualize that thing. So obviously I would never do this with kids at this stage. I would maybe do it at 3rd and 4th grade with this. So turn to your partner. And so, for instance, let's just pretend for a minute. Is it Christina? Can I pretend like I'm doing it with you? So go ahead and just say 1 or...
1, 2.
Okay, 1, 2, and I might go 3, 4. Then you go 5, 6, and then I might go 7. Then she'd go... 9, 10. Do you see what I'm doing? And whoever gets to 21, whoever says 21 is the winner. Turn to your partner and try that. Only use 1 and 2. And you can't say, I don't want to do it. Okay, everybody, I hate to stop you, but I want to illustrate a couple points here. Why do I do this with kids? I don't do race for 21, I do race for 11, okay? There's a pattern to this. Because I want them to see what 11 looks like. And oftentimes when I'm playing with them, I will play a game with them and say, well, how many more do you need to make 10? And how many more? So I'm always working on that idea of what that looks like. But here's another thing I do with it. I say, comes to be parent night. We're getting close to parent night. And I say, call up a small group of kids who play. These are choice games. I put them in the centers and they play them. Those that are interested, I'll call group and I'll say, you know what, you guys? I know how to win every time on this game. And it's not because I'm smart, but it's because I know the pattern. If you can figure out the pattern, you can win every time. Wouldn't it be fun to have your parents come and beat them? Wouldn't that be fun? So we end up doing it, and they love it. So, but I've got to show you, because you have to find the pattern. Is there somebody that's really brave in this room that will play me? I will win. I do this with my group of kids too. No, I will win, but you have to be really brave to kind of show. Is there anybody here that would play? All right, come on up here. Yes, she was.
the wonderful teacher in my class today. Thank you. Okay. Now, when we're partners, anytime I'm a partner with a child, I do this routine.
Oh, hi.
We have to shake hands, and we will be very good partners, I can tell.
Absolutely.
All right. So you go first.
Oh, how generous. 1, 2.
And what's interesting, everybody, is when the only way I know to win this game is if they go first.
Really?
Yeah.
Oh,
That's the only way I
yeah.
know to win. Yeah. But listen, note that parents get all excited. They say, they were so nice, they let me go first. I just love it because it's so funny. All right, so you said 1, 2. Now remember, you're looking for a pattern in what I'm going to do. Okay? Children don't recognize the pattern for quite a while because they're too busy looking at you. But she put 2, I'm going to put 1.
Do you need me to do anything to
Keep going. No, you can do whatever you want.
4.
No, you can't do 4.
I mean, the number.
Oh, I'm sorry. Okay. I got you. You're doing the verbal one. I just was meaning. So you just want to put in 1. Okay. And I will put in 2.
Good for you. I'm going to put in 2.
She'll put in 2, and I will put in 1.
I do an opposite of me.
Ah, really?
5.
Okay. Oh my gosh, you get me so confused. Okay, 1. I'm going to do 2.
2.
And I'm going to do 1.
1.
And I'm going to do 2. And I'm going to do 1. Yeah.
I almost won.
Give you a hand. Thank you for doing that. 21 has 7 sets of 3. So if they give me, and the kids, I don't explain this, but if I give 1, they put in 2. If I put in 2, they put in 1, and so on. And the kids get that. Do you see the sequence? Again, my main goal is that, honestly, that they see that what it looks like, and they fill up that 10 frame, because that's a wonderful model for them to use, and it makes a lot of sense. 5 Creatures is a wonderful book that I gave the copy of to this preschool today. It looks at part whole relationships, which is what I used it, but I've been doing something different with it, and I'm going to skip this tape. It's a new one, but I think it's one that makes sense. What I do now is I have them, from that book, you can do a lot of things, but I have them draw a picture of their family, okay? And by that, I mean any creature who lives, it's called 5 Creatures, any creature who lives at their home, which could be any animals. I do not discuss what makes a family. Anybody that lives at their home or where they live is just fine to count. And they draw pictures of them. This is at the beginning of the year. And then I take Unifix cubes. Take a Unifix cube and put 1 on every creature that they have. It's a very tall family. They then put those cubes together and they compare the numbers in their family. Now, what I like about this is we write a book every week in the classes that I teach. Most of them are math, obviously, because that's what I'm doing. So what we do, this was at the beginning of the year, everybody takes their towers. So if they had 5, they have 5 Unifix cubes in their tower. If they have 12, they have 12 Unifix cubes in their tower. They always feel sorry for Mrs. Copley because she only has 2 and she's very happy. There's no animals. There's just a husband. Yay, I like that. So mine is always the little one, and they go, oh. And I go, that's good. It's fine. Then we put our pages to match the Unifix cubes, towers. So everybody that has 3 puts theirs in a pile. Everybody that has 4, so they're matching. They're not necessarily counting, but they're matching the size of the tower. What is wonderful about that is this. They then, we make books, and we make a book, and these are class books that stay, so we have a book for 3 creatures, and everybody that has 3 creatures in their class puts it in that notebook. Everybody that has 4 creatures puts it in the 4, 1, 5, 6. In the class I was in, when we got to 12, we just said 12 and more, and there were plenty of those in the classes that I teach. So we put them there. Now here's the kicker, and here's what's neat. What happens is in morning news, when someone said, I got a new puppy, I got a new sister, got a new Uncle Jim came to live with us, whatever, then they have to add that to their page, and then they have to change their page to another book. One thing we know is that no one ever leaves our family. We're always part of the family. So if a pet dies or somebody leaves, they really haven't left. They're always still in our hearts. So they never can go down in pages. They only go up. What's nice about that is it really helps them in the counting on process and thinking about what that is. One year we had a mother who had triplets. Oh my, that was really exciting. What book are you going to be in today? Because we weren't sure how to quite get +3 going on that one. Do you see? But it really makes a nice thing. It's a great beginning of the year activity, if you haven't seen it. This just brings up another comparing activity with tomato. This is on the outside of one of my books. This is we cannot cook in Texas in classrooms anymore, which just is so upsetting to me because a lot of my stuff dealt with that. So we were making pizza, and they were doing tomatoes, having tomato sauce and stuff, and I always have them cut out, and I have a cutting and folding center because I think it's good fine motor for them, but they were cutting out tomatoes, and then they had to put whether they liked it or not. And so we had 10 people who liked tomatoes and 6 people who didn't, and that was just part of the comparison. So I just wanted you to see that as an illustration. Well, it is now time for geometry. And geometry is just one of my favorites. I could talk about that forever. But so that I don't have to talk about it forever, here's what I'm going to give you a couple things. So listen carefully. At the end of your tables, you have, or into the rows, you have a thing of Post-it notes. Here's what I need you to do. I need everybody, in just a few minutes, you can start passing them down the road. I want you to take 2 of those Post-it notes off. Okay, 2, everybody's going to need 2 Post-it notes. And so it's going to go all the way down to the end, and make sure everybody gets 2. Because with the 2, you are going to put together a particular plan. We're going to do some geometry tonight. And I was going to have you go eat during this time, but frankly, I would lose probably 25 minutes with you going to get food. So here's what I'm going to do. I'm going to tell you how to do this activity, and then I promise you I'll stop before 9 so that we can eat, okay? Because there's some really good stuff over there. But I don't want to lose you right now because you're with me so far. And if you just can't stand it, you can go over and get food and I'll never notice because I teach, whatever. Okay, take your 2 Post-it notes, and I'm going to steal yours for just a minute. What I need you to do, remember I told you I have a folding and cutting center? I do lots of folding and cutting. Right now what you're going to do with these, you're going to fold them into triangles. Now, one each square, so you're going to end up with 2 triangles. You know how it's sticky? By the way, this is the cheapest square you're going to get. It's a real square. I love it. I used to spend all my time cutting squares for kids, and they never were right, and whatever, you know that. So we do the sticky side, and we make like a taco, is what we say. Bring up the tip, and we go zip, zip, zip. Okay? Everybody kind of got that? Zip, zip, zip. We do everything auditorily. It just that's how life is. So you need to make 2. Now, in my center, folding kind center, I have a big bucket that has a big smile on it, and that's where they put the ones they make that they like. I also have a big bucket that has an uh-oh face on it, kind of a sad face, uh-oh, so they get practice. Their job may be to make 2 triangles. They put the 2 they like in here and the other ones that don't come out, and then they become my scrap paper. So it works. So I made one for you. So everybody's going to need 2 because you're going to use the 2 you have with your partner's 2 to do one of the activities that we have. Okay? And we will get started. What is geometry? While you're doing that, what is geometry? Well, geometry is really 3 things. It's shape, understanding shape and decomposing shapes and putting them together, so you were right with that. It's also spatial orientation. Where am I in space? It's all those spatial words that you use. And some of you, did someone think they were spacey? Is that I don't know. But anyway, where are you in space? Are you under, over? It's all of those spatial terms that are very important for kids to know. And spatial visualization, which is the thing we forget. And I'm going to do quite a bit. That's what I'm going to do with the triangles with you. Young children doing geometry. We do a semi-Venn diagram. I give them paper plates. And I give them, in this plate, these are made by 4-year-olds. You see, this plate, the word on the back of the plate that they had made was yellow. You see, it was the word yellow. So they put all yellow shapes. And our job is to guess what what those shapes all have in common. Do you see how that's a nice Venn diagram? What do you think the word over here is? Circle. So we do lots of those kinds of activities if it's in, and everybody does one, so we have 21, 25 puzzles that we have to see if we can figure out. It's a nice way to begin that. Now you just made 4 triangle shapes. If we had time, I would have you put those 4 triangle shapes together. We don't have time to do that part, but I will let you know. Again, I apologize. Aren't you glad you sat up front? That's just marvelous. Okay, what happens is if you put these 4 shapes together, you match the sides exactly, and I put these two together, and I'm going to take these 2. You can actually make 18 different shapes. So let's say I put this one here. That is actually a hexagon because it has 6 sides. Now, it doesn't look like a hexagon because we only think hexagons are the yellow pattern block that is a regular hexagon, but that has 6 sides, so that is a hexagon. So just with using 4 shapes, kids can experiment, make all kinds of things. It's very hard in this setting to do that, but it's a really neat activity and makes a lot of sense. Well, I want us to do an activity that I call Look, Make, and Fix. This is the spatial visualization activity I was talking about. What does spatial visualization mean? It means that I can visualize what something looks like and not necessarily be able to see it at first. I can look at it and then make it and then come back and look back at the object. So I'm able to remember stuff. Now think about this for just a minute. Have you ever had somebody give you directions to go someplace? And you're like, I don't know about you, but I'm not much good at this. You know, turn right, do this, go north, go north. I hate the ones that go north so much and then south, and I'm thinking, so what does that mean? Which way do I turn? It's dark. I don't know which way is north. Never could do that very well. But it's that idea that you can picture where you're going. Now, I'm the kind of person that turns the map over to make sure I'm in the right perspective. I don't know about any of you. I may have just ruined your whole view of me. I don't know, but that's the truth. I have a hard time with that visualization part. My husband is a builder. He can walk in this room and tell you exactly how much paint he needs or how much, if he's going to build something, how many feet it would be, whatever. I go in and go, I have no idea. I can't visualize the stuff like he can. So this takes practice, and almost every IQ test uses, or testing of whatever, uses, you know how they say, does this shape look like this if you put it over here? You know those ones? But we give very few, kids don't have many experiences with that. So this is called Look, Make, or Fix. Here's what I do. I have my 4 triangles on a magnet board, okay? I will tell you, I used to think this was too hard for kids. I am wrong. It is not too hard. It's something they love and they do it. So here are the rules. First of all, I'm going to make something for you. And you are going to look at it. You are not to touch your shapes while you're looking at it. So you put those down. Don't you try to make it at this point, okay? You're going to look at it. I'm going to show it to you, and someone will know that you're touching it if you are, okay? Then I'm going to have you put them, then I'm going to turn it around, and I'm going to say make it. From your memory, you have to make it. And then I'll turn it around and you fix it. Do you get the idea? So there's no right or wrong other than you are in charge of fixing it. Okay? I'm going to show you a sample of kids doing it. I promise you, well, I won't know if you're really bad at this, but some of you will be. That's how that usually works. Okay. All right. So I'm going to do one. I'll try to do one that is that I've done with the kids, because right now we've done a lot of them, and the kids are really getting good at this. Okay, this is one I did a couple weeks ago. It's really good. You ready? No touching. By the way, you may talk to a friend and say, how are you going to, talk about how you're going to remember it, and because I think the verbalization is great. Okay, you ready? Look. Welcome to talk about it. You can talk about it right now. Okay. Make. All right, ready? Fix. Yes. I think this was entirely too easy, so I'll try a different one. You ready? Ready? Look. Okay, I want you to know that I am not good at this myself, and I've had to really work on it. It's something that is a little different. Let me show you a video clip of a group of children. Now, I need you to know the background of this. NAEYC was working with me on this new revised version of the Young Child of Mathematics, and they wanted very much for me to do a tape for this, and I didn't have one. And so I had to go into a class, and I'll tell you what I was thinking on the way in. We haven't done this before. This is new. Usually I start by doing one that has one circle, a square, and I would never do tangram pieces, which is I would never do that at first, but that's what I needed to illustrate. So it was one of those cases where I went in going, ugh, this is not going to be good, they're not going to do well, but at least maybe it would show an example of what could be doing. And I was totally wrong. This is the first time they have done this activity. One thing you need to know, most of the time, if we're doing a whole group thing, I'm sitting in a big circle. But in this particular case, obviously, if people are sitting on this side, their perspective is very different. So the kids have to sit facing me in rows. And so I'm just explaining that's one of the kind of parts. But I want you to see how well they do. Again, these are 3- and 4-year-olds, mostly 4s in this particular class. This is a Head Start site. Are you ready? Look. You gotta put it in your head. Don't touch your shape. No touching shapes yet. This is still the look. Talk to your friend and talk to the person next to you and say, how are you going to remember this? So they all how are you going to tell them? I do that 100 times. Tell them how you're going to remember it. And they ask, David. Okay, are you ready? All right. Make it. Empty your shape. See if you can make it. You don't need all of your shapes for this. You may only need just a couple. The problem is just get out of the bag. Remember what it looked like. Boy. You can help These are tangram pieces, so they're different sizes of triangles.
Look, I make it. I make it too.
Tell the person next to you. Maybe they want to help.
Yes. I make it.
Some of them look a little different. Not everybody's looks the same. Put the shapes you don't need back in the bag.
Look at mine.
Put the shapes you don't need back in the bag. I can tell this is one.
I did it.
Okay, we're going to fix in just a minute. I'm going to turn it around in just a minute. All right, you ready to look?
Yes.
Okay, you look, you made. Now, this step is fixed. That means you look at it and see if yours looks exactly like it. If it doesn't, you fix it. Make it look like, okay? All right, you ready? Here we go. Look at this one is bigger triangle, and this one is a smaller triangle.
This is a hard one, 5 pieces. Just look at it. Just
Sounded
look
a
at
little
it.
like
Don't
you,
touch.
actually. Yeah.
Tell somebody next to you. How are you going to remember this, you guys? How are you going to remember it? What are you going to do?
I did the same dumb
Never did
question.
that right. Oh, I heard somebody over here saying they're remembering it has lots of triangles. That's a good way to remember.
Thank you.
Look at the shapes. Look at the sizes of the triangles.
Awesome.
Okay, nobody's touching yet. You think you're ready?
Yes.
All right. Make.
Make me.
You don't need all your shapes. Let's see.
I can use my nails. I make it. I can make it already. I can make it.
See, they're focused on triangle, not size.
Boy, I used 5 shapes. I hope you've used 5 shapes.
It's
5
finished.
shapes. You had to make it just like I did. Do you remember what sizes, what they look like?
I made it. I make it. I made it. Look, I made it. Okay. What's the face right here? I make it. I make it. How do you make?
Only worry about yours.
Do you see the square that top of the Christmas tree? Visualization is very important, and one of the things I do is I take block pictures of buildings in Houston. We're right in the middle of the city, so there's plenty of those buildings. And I take photographs of them and put them in the block center. And we look at the two-dimensional picture and try to build those buildings. It's a very good way for them to transfer two-dimensional to three-dimensional and work at it from here. We play a game that's called the Tower Game, and there's many video clips of this where they roll a die and they try to build blocks on top of the paper, and if they get 2, and of course now they're saying, yes, it stood. But what's fascinating to me is how many children really do not really know how blocks stack. And the idea that I've had so many children put a sphere on top of the tower and wonder why it rolled off. And that's really what we should be doing with geometry, is looking at how the shapes fit together and how they compose to build new things. I'm not going to show you this tape because of our time, but if we look at this, I love this because remember I told you pattern and geometry works, pattern works with everything. This little girl, I have what I call tents that the kids have. Each child in my class has 2 tents, which are just index cards folded with their picture on the front with their name on it. And they get 1 picture a week of something they've done that they're very proud of. And they will put the tent by it. That means no one can touch it until I take a picture. And that becomes part of their portfolio. And I love that because they decide one thing they really like. I decide something else. So I put 2 things in their portfolio a week in a typical classroom. This little girl wanted to do this. She was so excited. She said, I made a pattern with my blocks. And I said, oh, great, could you read your pattern to me? Because I always have them read the pattern from left to right. So she went down, up, down, up, down, up, down, up, up, down, up. And I said, I'm really puzzled by the over here. And I wish you could have seen her. I don't even remember her name, but I remember the person she was talking about. She goes, Jeffrey took my block and would not give me the one I wanted so I could be down, and I'm just, I mean, she just was. And I remember Jeffrey well. He was one of those that you remember well. And I thought, I looked at the block, and, in my mind, I'm thinking she could have put it down. So I called Jeffrey over and said, Jeffrey, I forget the little girl's name, but so-and-so is very upset about this block that you did not learn to use. And he went over and looked at it and went, picked it up, turned it over and went, and walked out. And she's going, oh. It's amazing to me how kids don't see the different orientations, and this is just an example of that particular thing. You see the little Mylar that's down, I don't know if you guys have Mylar paper here. We have so much sun that comes in our windows that oftentimes they'll put that Mylar that they get at the hardware store that are reflective pieces. We'll put in windows. I can tell that's not a problem here. When I talk to Texas people, they'll go, oh, yeah. But I put Mylar in building things, and did you notice I have lots of different types of blocks? I'm a believer, yes, I love Carolyn Pratt blocks, unit blocks. I think those are marvelous, but I also put in a lot of other ones because they give them other things to look at.
and to experiment with. But I put Mylar papers in there and maybe put them on tag board. You can get it at hardware stores. And it's wonderful for them to have the reflective pieces to look at behind the shape and in front of the shape and all around. It's a very important aspect. Now, what this is, and this is what you need to know, kids will build with blocks for me. I will take the picture of the blocks. So this is the photo of the blocks. My husband's a builder, I told you, and he brings some of his plans in so that they can see what they look like. So I take white butcher paper and black crayon, and I take a picture of what they built, which is what this is on the side, and then they draw it. They make the plan. They draw it with their black crayon on white paper. We roll it. I attach the picture to the paper, and then I write architect John Smith, or whoever the child that did it, and we roll it up, and we have a whole set of building plans in the block center. So kids go over and build, take it out, open it up, and build Jonathan's plan. Now that is so neat because I can't tell you how many times I've heard in line, or when they're going someplace, I builded your plan today. And then I've talked about when you build somebody's plan, you need to call them over and they need to inspect it and see if it makes sense. You see how, practical stuff that relates directly to geometry, but as well as to life. This is Mark. He built this. I think it's pretty cool. This is him, that he got out that plan. So I laminate these, put them in the center, and the kids use them. Do you get the idea? It's a neat way to do it, I think. Another thing that this took me, I'm embarrassed to tell you, I didn't figure this next thing out till about 6 years ago. And I've been doing this a long time. How stupid of me not to have thought of this. Have you ever had something like that where you go, duh? How could I be so silly? For years, I've had kids bring in spheres, bring in balls, bring in boxes, bring in everything I can, so we have a bunch of shapes, of three-dimensional shapes, and that we pass around, everybody pass around, because I can always go get blocks from someone, but I never have enough pyramids, I never have enough stuff, you know what I'm saying? And so I like kids to be holding something as I'm talking about it, or as we're talking about it, or moving it. So suddenly it hit me, why not use Play-Doh? And why not have everybody make something at the same time that we are all, and we're talking about it, and we're looking at the attributes of three-dimensional shapes. So here's the phrases I use, and I'm going to show you a video clip of this because it just, I think, tells it so much better. Looks like a ball, it's a sphere. I use correct language. I'll say it looks like a ball, but I call it a sphere. And what I'm going to do is most of my kids have transformers or whatever, so I simply pick up a thing and I'll put it in the middle. I teach this as a small group, as you'll see, and I pick it up and go, all right, you ready? Looks like a ball. I call it a sphere, and I put it down the middle and I say, transform. Now you're going to see me doing it along with them because I'm purposely talking a lot. The reason I'm talking a lot is we're going to be talking about I'm saying, ooh, we got to make it roll. We got to listen. You'll listen to my language because this is the language I want them to get. Looks like a can, it's a cylinder. Looks like a box, it's a rectangular prism. Cube, I know you're wondering about cube. The fact is a cube is a special kind of rectangular prism, and it's for another time and place probably. But anyway, so watch the tape, if you will. This is taught in a small group. You'll see why in a minute. Transform. Make a shape just like that. I call it a ball. I could call it a sphere. Now make one. Ooh, I'm going to roll mine. Are you rolling yours? Oh, I want to make it smooth. I got some humps in mine. I got to make it smooth. Can you make it smooth?
I can make mine smooth.
Can you use all your Play-Doh to make it smooth?
I can make
Use all your Play-Doh. Can you use all of your Play-Doh? Can you use all of it? And it's got to roll if it works. Let's see. Oh yeah, mine rolls pretty good. Oh, could I help you? Would you help me make mine and I'll help you make yours? I'm gonna roll it.
I made mine.
If it's a sphere, it's got to roll and have no corners sticking out. Oh boy.
No corners sticking out.
No corners sticking out. It's got to be smooth and roll.
Mine is. I can't do mine. I got it.
Here, can I help you do?
I can't do mine. I can't do mine.
Here, would you do mine? Would you work with mine, please?
You can do mine.
No, yours looks good. Keep rolling. Make sure it's smooth. It's smooth and it can roll. This is called, it's like a ball, isn't it? But you know what I call it? I call it a sphere. A sphere. Have you ever heard sphere? That's a big word, sphere. Can you say that? Sphere. Oh, you've got it. All right, now put that in your plate. I'm ready to do the next one. Are you ready? Leave it down for a minute because I'm going to put another one. This was a ball. Put your hands like this, everybody. Hands like this. Here we go. Are you ready for the next one? All right. Transform.
A circle.
It's like a can,
But it's like a pipe.
but I call it like it's like a pipe. I call it a cylinder.
Looks like a pipe.
So everybody try your own for a minute. I'm going to roll it like this. See how I'm rolling it? Because I want it to be smooth. And then I'm going to make it flat. But see how it's flat on top? I better turn it over. Roll it, see, roll it, roll it. Here, would you help me with mine? And I'll help you with yours. I'm going to take all of it. I'll help you with yours in a minute.
That I'm
Okay,
giving
I'm
someone
going to
help
roll
me
it,
that
make
I'm
it
going
kind of like,
to do theirs.
see, it's kind of like, it's like a can, smooth on, oh yeah, boy, yours is good. Roll it. Oh, they look good. Now make them flat on the bottom. Make them flat on the
Do you get the idea? Could you also tell that we're from the South? A little different there. Do a lot of quilts. This is a quilt made in a four-year-old classroom. It took up the whole piece. What we did, their job is I give them a big white piece of paper, and they have to order. I had some fifth grade kids come down. This was at a school that was an elementary school, and they were in charge of the quilt shop. And the kids had to go up and use their words and tell what color they wanted and what shape they wanted. So they had to tell whether it was a rectangle or a square. And all these dimensions, by the way, are in one of the books I wrote. But if you need those and want to do it, you can email me and I'll give that to you. As you look at these, this was a big sheet of construction paper every child had. The neatest part is on family night, they had to stand in front of it and tell where their quilt piece was, and their parents had to find it. And they did it by talking about the colors and the shapes. I mean, mine's on the top row, and can you hear all the wonderful words that they were using? And they were so proud of it. It's actually beautiful, don't you think? This is what we did at the end of the year. We take triangles and put them together into a quilt. This is much harder. Sometimes I don't get to this because it's much harder to put it in. They have to cover up all the white spaces. You see the little boy at the far side is doing it fine. This little girl is going to have trouble getting all those pieces in there and putting it there. But when it's done, it looks beautiful. Can you see the quilt? It's very, very nice. And again, what they're doing is decomposing and composing shapes. These are all objectives that are very important for geometry. So you see, it's a whole lot more than name and shapes, isn't it? Yeah, a lot different. Measurement, I'm just going to very briefly go through this. There's so many things for me to tell you with measurement, but the most important thing is one that I can illustrate. So here's what I want you to do. I want everybody right now on a piece of paper, or tell your neighbor if they're not sure you'll do it or whatever. I want you to write down the number of snaps you can do in 1 minute if you never got tired and you were snapping as fast as you could. Let me illustrate what a snap is. This is a Fermi. Enrico Fermi out of the University of Chicago wrote a lot of these problems, which is something we'd never be able to solve. Okay, this is one snap. Oh, no snapping now. You've all snapped in your life. I don't want any early snapping. But this is what a snap is. This is one. If you are a two-handed snapper, you might do this routine. If you do it like this, it only counts as one. But this would count as 1, 2, whatever. Okay? So write down a number. How many snaps could you do if you went as fast as you could and you never got tired? Write it down in 1 minute. Write down on a piece of paper. Or tell your neighbors so you won't change your answer. Okay, you ready? Everybody got that? Well, I'm not going to do it for a minute, but I'm going to do a sample for 10 seconds. You're going to snap as fast as you can for 10 seconds, then you'll multiply that number by 6 for a better estimate, really. It's still not going to be right because you're going to get tired in 10 seconds, okay? So, are you ready? All right, ready, go. Stop. Multiply it by 6.
How many people underestimated? Raise your hand. Very typical. Most people do. Why do I do that? Well, usually I do it with a lot more finesse and a lot of other things, but here's what I want you to know. This is the whole idea of measurement in a nutshell. Children need experiences to be able to do measurement well. And we need to give them experiences in measurement. Now, you didn't do very well in that. If I was giving you a grade on how well you estimated, I didn't look at it. Most of you would do very poorly. Be a very bad grade. Because you weren't very good at it. You knew what a snap was, and you knew what a minute was. You could even define minute, couldn't you? But the fact is, you'd never done them together. You can teach children what an inch is or what a whatever is, or length, but if you don't give them lots and lots of practice, they don't get it. If you've ever driven in Europe and tried to figure out how long it take you to go so many kilometers, if you haven't, you can be able to define it, but if you haven't had experiences with it, you have trouble, right? So my main goal is to give children experiences. A little boy said to me, Miss Copley, I'm taller than you. And I said, draw me a picture, show me. He did. Right? He is taller than me in that picture, right? Again, he was learning, and that's one of the things, because there's so many processes of measurement that kids need to learn. This just gives you, they use perceptual clues to compare. I know you know that. But again, they do know that these attributes exist. I don't have time to go into all of these tonight, but what I'd like to do is show you a couple examples. And again, if you do want the handout, you can get it and get this information. I love the book Actual Size, because if you haven't seen it, and for a while down at our place, and I don't own any part of Kohl's, but they were selling it for $5, and I bought about 10 of them and gave them away because they're really neat. But in that book, How Tall Are You?, it has the big elephant feet. So what I did is I took the elephant feet, which is on the left, I took my size feet and then my grandson's little baby feet, and the kids measured how tall they were in those feet. What was interesting was I kept saying, I just don't get it. I think elephant feet are big, and I only am 3 elephant feet tall. And the baby feet are little, and I'm a whole bunch of those. Ugh, I don't get that. That's the inverse relationship in measurement. It's a very important one, but Mrs. Copley keeps having confusion with it, and so we just keep doing many of those kinds of things. I have one of my favorite things to do is we make cars. When I taught a lot of science and math together, and so we made cars that rolled down ramps, and we did a whole bunch of stuff with that. But they bring cars from home, and we measure how far they go. Coming down the ramp, how far do they travel? And the kids pick the very best car, and I do this routine. I say, my car, I'm going to bring a car tomorrow, and mine's going to go farther than anybody's. I'm so excited. And the kids are going, oh, because they know I do this quite often. Mine's going to go farther than anybody's. Well, let's measure how far yours goes, because only one car can fit on the ramp. So we measure, and we measure using licorice sticks, because those are my favorite things. So we measure using licorice sticks, and we'll maybe get 5, let's say 5. It varies every year. So this car went 5 licorice sticks, and we write it up, 5 licorice sticks. I'm so proud, yay, yay, yay. But tomorrow, the car I bring is going to go farther. Now, I will tell you, I've had this car a long time. It's terrible. It barely makes it down the ramp and goes about this far. And I know that. And I bring it and put it on the desk or high up. I don't let anybody test it. We'll test it at the end of the day. So all day long, it's, your car's not going to go as far. Yeah. Oh, yeah, it is. Yep. It is. It's going to go farther. So I just can't wait. And you can understand how excited we get when we do that. So we're getting ready for the big test, okay? Put my car on. I'm excited. Let it go down, and it goes just, and the kids are, yay! And I went, we've got to measure. It was done with licorice sticks. So I bring out a licorice stick, and my licorice stick is only this big. And I use it, and I count 1, 2, 3, 4, 5, 6, 7, 8, 10 licorice sticks. Yay! 10 is bigger than 5, and I put it up, and I'm all excited. Now, there's a couple kids that go, okay. Always. But most kids are going, that's not fair, that's not right. Well, what do you mean? I use licorice sticks. Now, I keep telling them I love licorice sticks, so finally somebody says, you ate it. I really don't like licorice sticks, it's just that works well. So, do you see what I'm trying to do? And it's what do you mean? Well, you gotta use licorice. I did, I counted, right? I did the thing. Yeah, I did. What's wrong? I don't get it. You know, Mrs. Copley needs a lot of help in thinking. Do you get the idea? So that when I say experiences, that's what I mean. Experiences that really help them do some thinking. This is one of my favorite things. I'll remember that I'm attached to this soon. I find their birth weight and their weight when they were, their length when they were born. And we make sand babies. And these are made with their, we put sand in them, a Ziploc bag tied real tightly. And it's the right weight, and then I put a piece of adding machine tape that shows how long they were, and the kids get to hold their babies and then compare them, and we write books about when I was little I was like this and when I was big. It is actually one of the most wonderful things we do. You've got to understand, many of my kids are homeless. I teach in one school that all the homeless kids from the main shelter in town come there. And so when they have their own baby, it's just I could get really excited about math. Can you see? This is kind of, we're comparing the weights. These two little guys were two guys that had just been in a fight outside. Social skills are something that's very hard for our kids. And but when they held their babies, it was, you can hold my baby if you're very careful. And they switched babies, and it was just one of those nice moments. I use Margaret Miller's Now I'm Big book, and we write that book. When I was a baby, and then now that I'm big, we did the other page. Notice their babies are next to them, and it just is a wonderful thing. We compare the weights. Many of the kids, we can't get their weights for various reasons, so I have the average weight for a baby at that time, and we make theirs that way. I do have a quick funny story on that one. We have a discussion after they make their books about what they're going to put on when I was little, now that I'm big. And one little kid raised his hand and said, when I was little baby, I drank from a bottle. And I say, right, and now you drink from a cup. Very good. And someone came, when I was little, I drank from my... And I said, and now you drink from a cup. He said, yeah. It was like, oh gosh, I can't quite say that one, you know. It was so funny. It's important that they identify attributes and all of those kinds of things. Measuring with worms is something we do, and I just love this particular thing because I just tell them, tell me how long my arm is, and it's very interesting how kids misinterpret attributes, and they will call them this, for instance, this child is measuring the arm using worms. I do a lot of exploration. I don't know what this child is measuring. This is perimeter. The child is measuring the perimeter around the arm, this handprint. This child's measuring area. Do you see? Finding this. And again, we do a lot of experimentation, and then we come up, and Mrs. Copley only used 3 worms to measure her arm. Wow, I have a long arm, and you've used that whole pile. So we start trying to measure, how would we measure? And so I really work a lot on process of measuring, because that's where they are at this stage, not telling them how to measure, but just finding out ways that they can do it. I don't know what this child does either, but anyway. Here's my last story. My dad was a minister, and when he said, here's my last story, I got really excited. So this is it, guys. This is it. You've been really wonderful. But this is one of the schools right by the University of Houston is downtown Houston, and it's right in the middle of one of the rougher areas of town. But the university campus is beautiful. It's an inner city university. We have 35,000 students, so it's not a small place. It's a pretty big place. But one of the schools next to us is Cage Elementary, and it is a school that really you can't play outside. You have to play in the inner court because outside's kind of a rough place to be. But they have cement. They have these big cement blocks in the middle and no green. And one of my grad students who got his master's degree with me, he said, he told me about this. He said, I think we should grow vegetables. And then we'll have to write you and tell you how big they are and what they're like. So it became a wonderful process. These kids grew vegetables, and I mean they grew vegetables. They knew more about vegetables than I ever did. Look at their faces. I mean, this was harvest time, just so exciting. and just, oh, Miss Copley, it grew big, and well, how big? I need to know because I can't come over and see it today. So could you tell me about how big it is? What does it look like? But look at the greens that they have in here. This man, is this pride or not? This was a kid that had never done anything like this. It was the most exciting thing. We then took it to the gardener's corner, and I must confess I spent more at the gardener's center than I normally would spend for vegetables. But here's what happened. They made more than $140 by selling their produce. Now then what happened, we had to figure out how to make it fair, and what are you going to buy with $140? You see, these kids really learned about math through this project. It was one of my favorite things. Well, you guys have been so very, very nice to me. People have been so nice to me all day and said nice things. And you may say nice things today, and I don't know. But what I do know is this is the best compliment I've ever gotten. This came from a young child. I can't remember whether it was a kindergartner or a first grader. When I adopt a school, I adopt them for a couple, usually 3 years. And so this one nice thing about me is I don't have to teach the first couple weeks of school. Yay! It's not my favorite time at the beginning of the year, probably not yours either. I also don't have to teach at the end of the year. So I was saying goodbye to the kids and saying, I'll see you next year, I'll be back. And a little boy chased me out with my stuff, and he said, Miss Copley, you have so many problems. I'll just, come by next year anytime. By the way, we'll be in first grade. But come by anytime, and we'll help. Now, why is that a compliment? Well, to me it said they felt powerful in math. They could do it. They could solve problems. That's my goal, is to get them to really understand, but also to know that they can solve problems. I have included on this list just some these are the books that I've written or been a major part of, so I felt like I could put them up there. If you just type in Juanita Copley, you'll see these if you're interested in those kinds of things. This is my email address, and I'm very serious about this. I answer sometimes as many as 50 to 100 emails a day. I really try to give response. My goal in life is to share with people. I can't tell you any of these ideas are mine. I've taken them from many people. I've stolen from teachers. We've shared them. Anybody that tells you their ideas are all theirs, they're wrong. The fact is we do things with it. Now, I may rearrange them differently or try them differently, whatever. But it is a privilege to be a teacher that shares openly, and I'm more than happy to. So email me if there's something that's not clear. I don't know how they're going to disperse the handout if you want it, but again, if I can, it's just that it's very hard to do it over online. So if you are interested in anything, you're welcome to do that. I want to say to you, thank you very much for having me. Thanks. And now you get to eat, right? Is that correct? Okay, sorry, Carrie, I'll let you finish up.
Just a couple of announcements. We do have snacks, so please help yourself over there. I do not want to take them home. It's dangerous, so please help us out. Several of the courses that you are taking may have extra credit opportunities. There are a couple of sign-in sheets back there if you're a college student. Also, if you registered for continuing education units, you can go over to the back table there and get your certificate. And then also we will have the lecture tonight and other materials for you that Dr. Copley is sharing with us. On the HDFS website, there's a part in there labeled Hansen Lecture, and we will be posting materials and resources up there for you. So thank you for coming. Yes, Sue?